All right, welcome back to the second lesson in Unit 5. In this lesson, we will be looking at actually a lot of new definitions, new words, and we're going to explore what it means to have a relation, okay, and then, the meaning of domain and range. Okay, so here's some new vocabulary that we need to know. A set. A set is simply a collection of objects. Okay, so for example, whole numbers is a set, right? Because in that set, it has many objects, namely the numbers 0, 1, 2, 3, 4, 5, and so on. Okay, so that's a set. Okay, element is an element of a set. So for example, the example I just showed you, the whole numbers, the set of whole numbers, the elements would be 0, 1, 2, 3, 4, and 5, right? And so on. Those are the elements. Okay, so an element is a member of a set, and a set is simply it consists of many elements. Okay, so you can see here's the example. Here is a set city. The set city has 4 elements, namely Victoria, Toronto, Vancouver, and Halifax. Okay, province is also a set, right? It has 3 elements in this case. We have BC, Ontario, and Nova Scotia. You can see there are 2 BCs, right? So that count as just one element. Okay, so that's a set and element. Okay, so set is a collection of the objects, and those objects are the elements. Okay, so a relation is simply a relation between two sets is a collection of ordered pairs, okay, ordered pairs containing one object from each set. So for example, Victoria, BC is an ordered pair, right? Victoria, comma, BC. That would be an ordered pair. And how can we, here it says, can you use below table information to write a sentence about the relationship between each city and the province? You can say that Victoria, right, the city Victoria is located in BC, right? So that's how they are related. An order pair, again, one element from each set, right? The city Victoria is located in the province of British Columbia. Okay, so that's an element from each set. Okay, domain. Domain is a set of its all possible inputs. Okay, input are simply the x values, or we call them the independent variable. Okay, so we'll explore more about that later on. Independent variable. Okay, so city would be the independent variable here, or they are the inputs. Okay, or they are the if they are actually values, then they will be the x values. Okay, so they are the domain. Okay, domain is a set of its all possible inputs. So in this case, the domain will be Victoria, Toronto, Vancouver, and Halifax. Range, on the other hand, is just the set of its possible outputs. So the y values, or we call them the dependent variable. Dependent variable. Okay, so province, in the set of province, we have 3 outputs: British Columbia, Ontario, and Nova Scotia. Okay, so those are the range. Okay, those are the possible outputs. Okay, so we're gonna represent the above relation as a set of ordered pairs. Okay, so how you do that is you start with a squiggly bracket. Okay, so that represents the set. Okay, now order pairs, again, it's gonna be one from city and one from the province. So you're gonna start with bracket Victoria. Okay, that's the input, and the output is the province, which is BC. So that is one order pair. You can see you put them in brackets, just like how we label the coordinates, right, of a point. It's x value, comma, y value. So this is your input, comma, output. Okay, Victoria, BC. And then you also have Toronto, Ontario. And then you have the next set of order pairs. That's Vancouver, BC. And then the last one is Halifax and Nova Scotia. Okay, and then you're going to close it with a squiggly bracket. Okay, so that's how you represent a set. And you start the set, the symbol for a set is these squiggly bracket. Okay, so you open it, and you close it. Okay, and inside that set, you have 4 order pairs in this case. Okay, now the next way we can represent the relation here is a mapping diagram, okay, or sometimes it's called the arrow diagrams. So we have 2 bubbles, okay. The first bubble represent the first set. In this case, it's a city, and the second set is second bubble represent the second set, which is the province. Okay, so we have Victoria. So what we're gonna do is we're gonna list out all the elements within that set. Okay, so Victoria, Toronto, Vancouver, and Halifax. And in the province, we have BC, we have Ontario, and we have Nova Scotia. Okay, and now what we're going to do is we're going to draw arrows. Okay, so Victoria goes to BC, right? Because Victoria and BC are connected. Victoria is in BC. Toronto will then draw an arrow to Ontario. Vancouver, we will draw an arrow to BC. And then Halifax, we will draw an arrow to Nova Scotia. Okay, so that's how you show this relation in a arrow diagram. Okay, next, what is the domain of the above relation? So again, we said that domain is a set as well. So remember, anytime you're showing a set, you have to start with a squiggly bracket. The domain are simply the input. So the cities, in this case, Victoria, Toronto, Vancouver, and Halifax. Okay, so that's a set. Again, you start with a squiggly bracket and you close it with a squiggly bracket. Same thing for the range, that's just the output. So in this case, it's the province, right? So here we have BC, we have Ontario, and we have Nova Scotia. Notice how I did not write BC twice. Okay, so again, they are just the same element. They just happened to occur twice. That's all. Okay, but you just need to write it once. Okay, so that is essentially what these words are, right? A set, element, relation, domain, and range. Okay, so a relation is basically a relation between 2 sets. Okay, and we will have order pairs from each object. You'll get an element from each object from each set. Okay, and that creates a relation. Okay, so that's that. Let's go over to the next page. Graphing. Okay, so we've done some graphs in Math 8 and 9. Let's quickly review the Cartesian grid right here. Okay, so origin, remember, is just the point 0, 0. That is right here. Here's the origin, right? X-axis is the horizontal axis. You can see it's right here. Here's the x-axis, right? The y-axis is the vertical axis. And that's this one right here. That's your vertical axis. Quadrant 1. Okay, so this might be new. Quadrant 1 is the top right corner. Okay, so all of these, okay, all of that region, okay, is quadrant 1. And this will be quadrant 2, quadrant 3, and quadrant 4. Okay, so it rotates in a counterclock direction. Okay, so those are the quadrants. Okay, now let's look at this graph. Graph the following relation. So again, you can see here's the relation, and you can see it's a set, right? You can see the squiggly brackets there. Now there are 4 elements or 4 points in this relation, right? And it contains the one set from x. So these are the x values. Those are the x values. And the second element is the output. Okay, so those are the y values. Okay, so for the first point, 3, 7, hopefully you remember how to plot the points. Remember, we always start from the origin, 0, 0. When x is 3, we simply move 3 units to the right. So 1, 2, 3, and then the y value is 7, and y value, remember, is the vertical axis. And because it's positive 7, we're going to go up by 7. So that's 1, 2, 3, 4, 5, 6, 7. Here's my first point, 3, 7. Second point would be at -4 and 3. So again, start from origin. X is -4, so we're going to move 4 units to the left. And the y value is 3, so we're going to go up by 3. So there's our second point. The third point, let me label this as A, that's B. Okay, so here's my point A, here's my point B, point C, and point D, okay? -7 and -2, so my x value in this case is -7, so I'm going to move 7 units left from the origin. That'll be right here. Y value is -2, so moving 2 units down. There we go, there's our point C. Finally, the last point, 3 comma -8, again, so the x value is +3, so moving 3 units to the right by 3 units to the right from origin. -8 for the y value, so you move 8 units downwards, and there's your point D. So you can see we got 1 point from in each quadrant. Okay, so quadrant 1, point A is in quadrant 1, point B is in quadrant 2, point C is in quadrant 3, and point D is in quadrant 4. Okay, so that's just graphing. Okay. Representing relations, here's the example. It says use the table of values below to represent the data or to represent a relation as a, well, here you can see there is a table of values. We want to represent this relation as a mapping diagram. So recall, mapping diagrams means it's going to go from one set to the other. Okay, the one on the bubble on the left always represents the x, independent variable, or the input, okay, whatever you call it, it's the same thing here. And we have y values for the second bubble. So we have -3, -1, 2, 5, and -7. Now for the y values, we have 6, -7, 4, and -2. Again, you have two -7s. You do not need to write it down twice. Okay, all you need to do is just write it down once. And now you just draw arrows. -3 goes to 6, and -1 will map onto -7. 2 goes to 4. 5 goes to -2, and 7 goes to -7. There you go. So there's your mapping diagram. Okay, and we can write this as a set of ordered pairs. Okay, so again, set of ordered pairs. So again, the word set tells you that you need to draw the squiggly line bracket first. And then we just need to write down the ordered pairs. We have -3, comma 6, and then we have -1, comma -7. Okay, you could just look at the arrows and it tells you what they are. 2 to 4, 5 goes to -2, finally 7 goes to, -7 goes to -7. And you close with a squiggly bracket. Okay, if we want to graph it, you just need to plot the points. Okay, so we got -3 and 6. You know what, I'll let you do it. Okay, I'll let you do it. Okay, so hopefully you got this, -3 and 6, they'll be right here. -1, -7 is right here. 2 and 4. 2 and 4 is this point right here. 5 and -2 is right here. Finally, oh my gosh, I made a mistake. I just realized that, hey, my x value is actually +7, not -7. Oh, my bad. My bad. Okay, so here we go, 7 and -7. Here we go, 7 and -7. There you go. That's better. Okay, so these are my x. Let me just double check once again. That is correct. Okay, there you go. So we have 5 points, and that's how you represent this relation as a graph, right? You just simply plot the points. Okay, finally, what is the domain and range of this relation? So again, the domain, you need to write it as a set. So domain, usually we just write D. Domain, that looks like equal sign. Domain is a set of x values, right? And what are these x values? Well, they are -3, -1, 2, 5, and 7. Range is a set of y values. What are they? They are 6, -7, 4, and -2. Okay, so those are our domain and range. Okay, good. Hopefully it's not too bad. Again, it's just getting used to the new vocabulary. And once you understand what they are, it's actually not that bad. Okay. There you go. Here are 2 questions for you to practice. Okay, so you just need to state the domain and range for each set of ordered pairs. I show you how to do it with the above example, so these 2 are for you to try. Okay. Pause the video and I'll show you the answer in a bit. Okay, so here hopefully you get your domain as the -6, -1, 3, and 6. And range would be a set of y values, -4, 0, 5, and 2. For the second question, the domain will be a set of x values that are -3, 0, 3. Again, you don't need to write down -3 twice. For the range, will be a set of y values that are 6, 3, 8, and 9. Okay, so there we go. Okay, hopefully it's not too bad. Okay, now let's try to identify whether the graphs or this table is a linear relation or not. Okay, recall linear relation. I think the word pretty much tells the story, right? If you graph it, it should look like a line. Okay, so clearly part A is a linear relation because it looks like a line. Okay, part B is not a linear relation because, well, it's not a line, it's a curve. Okay, now part C is a bit tricky because it does look like a, well, it actually has two lines, right? It's not one single line like that. It just goes up or down. Okay, this one actually turns at a point, right? It goes this way, horizontal line, and then at this point, it just goes downwards. So this is actually a linear relation, and we actually call this the piecewise. We'll learn more about this piecewise thingy later on in Math 11 and 12, okay? Pre-Cal 11, Pre-Cal 12. But this is what we call the piecewise linear relation. Because you can see it's actually two lines, right? Two pieces. So we can break this into piece 1, and then we can have second piece right here. Okay, so this is what we call the piecewise linear relation. So it's a linear relation as well. Okay, it's also a linear relation. Okay, so that's how you tell from a graph. I mean, pretty clear, right? A linear relation means as long as you see a straight line, then that's a linear relation. How can we see, if a table represents a linear relation? Well, if you recall, we'll see about that. Linear relation, basically what you need to have is you need to have a pattern for both x and y. Okay, it has to either go up or down by the same amount. Okay, there must be a consistent pattern. Okay, so here you can see that's going up by 1, that's going up by 1, that's going up by 1. This is going up by 5, that's going up by 5, that's also going up by 5. So you can see the pattern is consistent. Now, you have to be careful though, okay? So because I can also do this. I can just skip 7 and put down an 8. So now this is plus 2. Now you might be, then in that case, it's not a linear relation because there's no consistent pattern. Well, it turns out it would be a linear relation if, this then goes up by 10. So then if this was 36, then yes, it would still be a linear relationship, right? Because when you double the pattern for the x, you also double the pattern for y. Well, then in that case, the pattern is still consistent, right? Because technically, I can put a 7 there, then I'll be plus 1, and then plus 1, then you plus 1 twice. And that means I can put 31 here. That means you plus 5 twice, right? So in that case, the pattern is actually still consistent. So in this case, yes, this is still linear. Yes, this is linear because the pattern for both x and y are consistent. Patterns for consistent. Okay, so in that case, we call that a linear relation. Okay, as long as one of the variables, x or y, the pattern is inconsistent, then it's not a linear relation. Okay, so there you go. Give it a try. See if you can figure out if these three tables and a graph are linear or not. Okay. Okay, I think the third one clearly is, right? Because that clearly follows a straight line pattern right there. Okay, now let's look at these two tables, okay? So this is going up by 1, by 1, by 1. Perfect. How about this? This is going down by 19. This is going down by 19. Also going down by 19. So yes, this one is a linear relation, right? Because you can see that the pattern is consistent, okay, for both the independent variable and the dependent variable, or input and output. Okay, how about the next one here? This is going up by 2, going up by 2, going up by 2. This is going up by 5, this is going up by 10, that's going up by 20. No, this is not a linear relation. Okay, so let me be clear, okay? So because I guess what I said is not only that the patterns are consistent, it's consistently, okay, let me rephrase this, because the pattern for both things are consistently going, both consistently increasing, well, this time it's both increasing, right? But it could also be decreasing by the same amount. Okay, so let me just, because I mean, you can see that's plus 5 plus 10 plus 20, so this one's not. But I mean, if you think about this as multiplication, that's times 2. That's times 2. That's also times 2. Oh, they're all multiplication, then how come they are not a linear relation? Okay, we'll learn more about this. This is what we call actually, this is not a linear relationship. This is something else, okay, because you're doubling each time, okay? Okay, you can think about that, what that means, right? Okay, double each time, hey? Interesting. Like I am multiplying by 2, by 2, by 2. That sounds like exponential. Anyways, we'll learn more about that later on in breakout 11, actually 12. Okay, but this one is not linear because you're going up. You're not going up by the same amount. Okay, you're not going up by the same amount. So this one is not linear relation. Okay, the last thing I need to show you is, okay, so I show you how to tell whether the table is linear or not, and I show you how to figure out if a graph is linear or not. What if from the equation perspective, okay? So linear equations is as linear relations can be represented by equations. These equations can be in one variable or two variables. Here are some samples of linear relations and non-linear relations. So you can see this is a linear relation. Okay, one variable, also one variable. This one has two variables and two variables. Okay, so now we're going to stop here. Now we're going to compare the ones on the right. And let's discuss why the ones on the right are not linear relation, right? So he says, what feature does an equation have to make it a linear relation? So he says this one is not a linear relation. How come? I mean, it has two variables. Okay, the problem with this is that the exponent for the variable is not 1. Okay, anytime you have an exponent for the variable that is not 1, it is automatically not linear. You can see the exponent here is 1, 1, 1, and 1. This one is a 2, so it's not. And therefore, you can see why the second one is not a linear relation, because you can see the exponent is a 2 here. Okay, so that's why that one is not. Okay, now the third one, x times y is 3. How come that one is not linear? Okay, so it turns out this one is not because, if you recall, let's actually isolate for y. Okay, so this is also the same as y equals 3 over x. And you might be like, okay, well the exponent is still 1, right? So what's wrong with this? However, if you write this, in the if we move x to the top, right? This can be written as 3 times x to the negative 1. Well, in that case, this exponent is no longer 1. Okay, so let me define that just a little bit more. Okay, so the exponent for a variable must be 1, and that the variable must be in the numerator. Okay, so and that is what happened here. This one is, again, you can see the the variable is in the denominator, and therefore this is not a linear relationship. So a variable must be on the or numerator place. Must be on the numerator side. Okay, so must be on the top. Okay. Finally, the last one. This one is not, because the variable is, well, that's the exponent, right? That's not a numerator. X is the exponent, so that one is not linear relationship. This is actually the exponential relation. Okay. Okay. Cool. So now we can try whether these are linear relations or not. Okay, give it a try. Okay, hopefully this one is, because again, you can see one variable only, and the variable is on the numerator side. This one is not, because the exponent for the variable is 2. This one is not. This one actually has 4 variables, right? V, L, W, H. This one is not. Okay, this is cubic function. This D is, okay, variable is 1 each. Okay, E as well. Okay, again, the exponents for each variable is 1, and they all appear on the numerator side. This one is not, again, because the exponent is not a 1. Okay, so that is it for this lesson. So we talk about, several of new vocabularies. Okay, so make sure you understand what they are. Where are we here? Here we go. These new words, you must understand what they are. Yeah, do some practice questions and let me know if you need some help. Okay, good luck.